Hello, geometry students, and welcome to your today's lesson. So today we are going to be focusing on equilateral and isosceles triangles. So what I would first like you to do is stop the video and then make an isosceles triangle. So you're going to need a straight edge or ruler here and measure all of the angles in the triangle. We should already know that they add up to 180 degrees. Okay, that is not something new. That is something that we already know. So measure all of the angles in the triangle and then make a conjecture from your findings. So go ahead and stop this video and go ahead and do that, and then start her up again when you are done and have made your conjecture. All right, so what you should have figured out or found out is that in an isosceles triangles, we obviously have two sides that are going to be congruent. But what else happened here is that these two angles down here, which we have a special name for them, and they are called base angles. Those two base angles are congruent in an isosceles triangle. So this is called your vertex angle and then your base angles. So we have your vertex angle and your base angles. And what happens in an isosceles triangle is that your two base angles are congruent. The two base angles are congruent. All right, so we have if, so back to our conditional statements, back from chapter 2, if a triangle is isosceles, then base angles are congruent. Okay, now what is the converse to this? What is the converse to the statement? So remember, it switches these two. So if base angles are congruent, then what can we conclude? That we have an isosceles triangle. If base angles congruent, then triangle is isosceles. So remember, when it's true both forward and back, it's like having a biconditional statement. So it's an if and only if, and that's what we call a definition. So in an equilateral triangle, you guys already know this, that all three sides are congruent and all three angles are congruent. So if we take 180 and we divide by 3, that means that each angle is going to be 60 degrees. So if we write that, if a triangle is equilateral, then it is equiangular. Again, what is the converse to that statement? So the converse is if equiangular, then equilateral. Okay, so this one is another biconditional, true forward and back. So this is a definition. All right, so in example 1 here, what kind of triangle? How would we classify this? Well, if you did it by sides, we'd say it's isosceles. And if we classified by angles, we would say acute. So what are the two base angles here? And it's angle G and angle F. And then our question down here is find the measure of angle F. So how would you go about doing that? What is your thought process? So stop it, give it a try, and then resume your video. So what I would do is take 180 and then I would subtract 22 from that. So when we take 180 and we subtract 22, we have 158 degrees. So 158 is left for both G and F, but we know G and F are congruent. So if we take that and divide by 2, we get 79 degrees. So angle F is 79 and angle G is 79. All right, find the values of X and Y. So you should really stop this video, pause it, do the math, and then come back and resume it to check it and see if you are doing it correctly. All right, my thought process here is we have an equilateral triangle, so we know that all of these sides are congruent. So if KL is 4, then Y must also be 4 because those are congruent. Then I jump to the other triangle, LMN, because these two base angles are congruent. That means these two sides are congruent. Well, if this side already has a single tick mark, then this side needs a single tick mark. And we already have a single tick mark as being 4. So this means x plus 1 must be equal to 4. So when we subtract 1 from both sides, we get x to be 3. All right, they didn't want to know any lengths of sides here, so we are done. All right, find the value of x and y. Again, stop the video, give it a try, and then resume it to come back. Don't just have me do it for you. You try it. You see if you can do this. All right, the first thing I see is that we have an equilateral triangle. So that means every angle here is all going to be congruent, and they're all 60 degrees. So x must be 60 degrees. Then we have this right angle mark here, which makes this be 60. So this little part in here, since that's a 90-degree angle, this has to be 30. And because this is an isosceles, the two base angles are both 30. So if we take 180 minus 30 minus 30, so what's that? 180 minus 60. So it looks like we're getting 120 degrees. Alrighty, so moving on. All right, the vertex angle of an isosceles triangle. So here we have a little diagram. So if we call this a plus 15, and one of the base angles is 7a. So 1 is 7a. So find a and each measure angle. All right, so we only know 2 angles here. So what's our process? Let's see. Base angles are congruent. So this one also has to be 7a. So a plus 15 plus 7a plus 7a must be equal to 180. So let's see, a, so that's 14. So we have 15a equals, and 180 minus 15 is 165. Now if we divide both sides by 15, it looks like a must be 11. All right, if a is 11, we can plug that in here. So it looks like we get both base angles are 77 degrees. And then if you take 180 minus 77 minus 77, that is going to get you your vertex angle. And I think when we do that, 26 degrees sound right? So we get the vertex angle to be 26 degrees. All right, again, pause the video. Make sure you're giving this a try so that you know what you're doing when you get to your homework. So we need to find x. All right, so this angle right here and this angle are going to be the same because we have isosceles. Now over here we have isosceles, so this angle must be 52. So this angle right here, remember that is a linear pair, and because that is a linear pair, that means they're supplementary. So 180 minus 52, I think that gives us 128 degrees for that. So now if we take 180 and we subtract 128 from that, we are going to get 52. So that means these two base angles, we have 52 degrees for that. So now we need to remember to divide by 2. And so we get x is 26 degrees. Now, we learned a different theorem in here earlier. And we learned a theorem that says this exterior angle here is equal to the sum of the two remote interiors. And since these are both x, this angle right here is 52 must be equal to those two remote interior angles, must be equal to 2x. So we can divide by 2 and we get x is 26. Now, that red way is easier or quicker. but we don't always remember that. So remember that we have the exterior angle is equal to the sum of the two remote interiors. So we can set up 2x equals 52 and we get 26 that way, or we could do it the long way, the first way I did it, and do it that way also. Okay, I think that brings us to homework time. All right, so good luck on your homework for today's lesson. Have a great day.